Okay guys, let's talk about electrons today on this video. And the very first thing we're going to talk about are valence electrons. Valence electrons are the electrons in the outermost energy level of an atom. And you're going to learn in just a few moments that there are 4 energy levels that we discuss. And so the electrons on the outermost energy level of the atom are called valence electrons. Now, valence electrons are actually what determine the chemical properties of the atom, like we discussed in the last video. It determines how flammable they are, how reactive they are. And the number of valence electrons equals the Roman numeral group number on the periodic table. Now, your periodic table does not have that. Now, let's go ahead and take the time. If you need to, pause the video, but you're going to need your periodic table today because we're fixing to label it, but you're also going to need to look at it for some information throughout this video. Okay, you should have your periodic table by now. Let's go ahead and get it out of your plastic sheet cover if you have it in there, because we're going to label it. Now, the modern way of labeling it would be to label 1 through 18. And so we just simply put every column has its own number. So to me, this is the easiest way to remember as far as how to go across the periodic table and label it. But in just a moment, you may choose that you may decide that you like the older way better. Now this is 1 through 18. This area right here, the transition metals, the dip, okay, we skip that most of the time. We skip over that. The 3 through 12 does not really help us out a whole lot. Now, this 1, 2, 13, 14, 15, 16, 17, 18, those help us know valence electrons. For this first column where hydrogen is, this has a 1 at the top. That means there's 1 valence electron. Beryllium's column, it has a 2 at the top, and that means this entire column has 2 valence electrons. Now, the only tricky thing about this type of numbering is you have to remember over here that you're just looking at the second number. So for boron's column, there's only 3 valence electrons. For carbon's column, there's 4 valence electrons. Nitrogen's column, there's 5 valence electrons. Oxygen's column, there's 6 valence electrons. Fluorine's column is 7 valence electrons. And then over here, the very last column, they have 8 valence electrons. And so you use the second number. So it's basically saying like 1, 2, 3, 4, 5, 6, 7, 8. So these tell you how many valence electrons each group has. Okay? And the columns are called groups, and you'll learn that in the next couple of videos. So let's practice really quick. Phosphorus, which is right here, has 5 valence electrons. Magnesium has 2 valence electrons. Fluorine has 7 valence electrons. Bromine has 7 valence electrons. I think you get the hint. Now, the old way of doing it, and you can label your table both ways if you like, the old way is using Roman numerals and skipping the transition metals. So that you have the 1, 2, 3, 4, 5, 6 like we were talking about. If you're not familiar with Roman numerals, this is 4. You have 1, 2, 3. I think you probably know those. This is 4. This is 5. 6. 7. And I know my writing on this is terrible with Roman numerals. I apologize. And then 8. Now, you're not going to be able to use your periodic table for my test or the EOCT. You have to use one given to you. So it's not going to be labeled like this. But my suggestion is just remember how to label it, and then you can label it on the EOCT like that, and I'm going to try to make sure on my test that you have sheet protectors so that you can write on the sheet protectors and label if you need to. Okay? So this is how we need to label it. Remember how to know how many valence electrons they have. The top numbers, let's look at boron just as a reminder. This top number is going to tell me it has 5 electrons, but then this number up here tells me 3 of them are on the outer energy level. So carbon, there's 6 electrons total, but there's going to be 4 on the outer energy level. Now let's look at those energy levels. We just labeled our periodic table, so let's go ahead and look at the energy levels we have. There are 4 types of orbitals. There's an s orbital, which is energy level 1, and it can hold 2 electrons. There's a p orbital, which is energy level 2, and it can hold 8 electrons. D is energy level 3. It can hold up to 18 electrons. And F is energy level 4, and it can hold up to 32 electrons. You need to know the 4 types of orbitals, S, P, D, and F, and you also need to know how many electrons they can hold. However, there's a little bit of a issue with D, level 3, and level 4. They can hold 18 and 32, but they don't like to hold 18 and 32 at first. So we follow the octet rule. An octet rule is just like it sounds because the OCT is a prefix that means 8. And so S energy level holds 2, P energy level holds 8 as usual, but the D actually likes to hold 8. And F also likes to hold 8. So we follow the octet rule, and you will never need to use D and F where they get larger than 8 electrons. So what you need to remember is that the octet rule is the first level holds 2 electrons, and then P, D, and F hold 8 electrons. Now D and F can hold more, but you'll learn more about that in chemistry. We just want to make sure we're following the octet rule and know that they're going to hold 8 first before they go more than that. Now, electron configuration. Electron configuration is a way to write which element that you're talking about and showing how many electrons are in each orbital. So this is used to show the orbitals and electrons in a certain element. An example is, and this looks so confusing, but an example is 1s squared, 2s squared, 2p to the 4th. And that's oxygen. Now, you do not have to know how to write these. You'll learn that in chemistry. But you do need to be able to know that that equals oxygen. And let me tell you how you do that. You take the exponents. The exponents are the numbers that are raised, right, the superscripts. And superscripts are the things above the letters or numbers are at the top, like Superman flies. Subscripts are numbers at the bottom, which we don't have here, but numbers at the bottom that float below the letters, like a submarine. So you take the superscripts, or the exponents, and you add them together. 2 plus 2 plus 4 equals 8. And if you'll look at your periodic table, look at oxygen, and you'll see that it has 8 electrons. So that tells you, when you add those exponents together, it tells you which element it is on the periodic table. And I've written the instructions right here just to determine which element is being represented. You add the powers together. The number they add up to is the atomic number, which is the number above the element on the periodic table. So that's how you match them up. Now, this is some practice, okay? So I want you to go ahead and let's practice this. And remember, you add the exponents together, look on your periodic table to figure out which element it is. Go ahead and pause the video, answer 1, 2, and 3, and then start the video again once you're ready to check your answers. Number 1 is chlorine, 2 is fluorine, and 3 is chromium. And we'll do a little bit more practice once we get in class as well. Now, there is another way to write the electron configuration where it's a shorthand so that you don't have to write that real long chain of letters and numbers out. And what it looks like is this. It has little brackets for neon and then say 3s squared. Now, if you look, neon is in the brackets. It has 10 electrons. 10 is the atomic number. Is you take this neon, and we just looked, it has 10 atomic numbers, so 10 electrons. So we say 10 plus any other exponents following. So we're going to say 10 plus 2 to get 12 electrons, which is magnesium. So again, here are the instructions written, but to determine which element is being represented by the shorthand, you simply add the atomic number of the element in the brackets to the number of powers following the brackets. Now, we're going to do some practice on that also. And remember, you look to see what's in the brackets, look at your periodic table to find the atomic number, and add it to the subsequent powers afterwards. So go ahead and pause the video, do 1, 2, and 3, and then resume the video once you're ready to check your answers. 1 is silver, 2 is erbium, 3 is potassium. So I hope you got all of those correct, but if you didn't, make sure you star them, and we'll talk about them once we get into class. Now, we have 2 more things we're going to talk about very quickly, and then we're going to practice it in class. There are 2 models that show electrons for elements. One is called the Bohr model, which you see here in front of you. And you need to remember with the Bohr model, electrons will always fill the first energy level. So this is actually neon. And neon has 10 electrons. So we draw the first energy level, as you see here. And we know that energy level 1 can only hold 2 electrons. So 2 electrons go on the first energy level. Well, if neon has 10, that means we still have 8 electrons to account for. So we go ahead and draw the second energy level. And we put, remember the second energy level can hold 8. So we put all 8 on the second energy level, and that shows us in the Bohr model of neon. And if you had, neon had 10, if you had 12 electrons, you draw the third energy level and put the last 2 electrons on that. Now remember, if we had the Bohr model to determine number of valence electrons, we would just count on this outer energy level, because whatever's on the outermost energy level is how many valence electrons they have. We're going to practice drawing tomorrow, so you don't have to draw tonight. But let's talk about Lewis dot structures. These, a Bohr model shows the total number of electrons for an element, and you might want to go and write that next to Bohr model to make sure that you remember it's the total number of electrons, because Lewis dot structures only show the valence electrons. They don't show the total number of electrons. Now, on your notes, you should have a box, and it shows you the order to place, the order to put your dots for the valence electrons. However, I am not picky, so you don't have to put them in this exact order. Just make sure you put 1 on each side before you start doubling up. That's going to be the only rule. Now we're going to take a quick look at an example for the Lewis dot structure for boron and show you how to draw that. Okay, if we have boron, and if you look on the periodic table, it says it's in column 13, or Roman numeral 3. And if you're looking at 13, you look at the second number for valence electrons. So we know that boron has 3 valence electrons. And so we can put 1 there, 1 here, and 1 here. Remember, I'm not going to be picky about if you put them in that exact order. I was just showing you the order. You could have put 1, 2, 3 this way. That's fine. Anyway, as long as you don't put 2 on one side together until all sides are full. Okay? And so this is how you do a Lewis structure. We'll also practice this in class tomorrow. The last thing for today, we need to talk about electron transitions. And electrons can jump between energy levels when an atom gains or loses energy. And so when they gain energy, that means they absorb a photon. And when they lose energy, they release a photon. Now, a photon is a particle of light. So light helps energize or de-energize an atom. Now, just think of electron transitions as a hotel with an elevator. The lowest state of energy for an electron is the ground state, or the ground floor of the hotel. When an electron absorbs a photon, it gains energy and it jumps to the second floor of the hotel. If the electron absorbs another photon, it gains more energy and jumps to the third floor of the hotel. However, when an electron loses energy, it releases a photon and falls back to a lower level. So, in other words, it rides the elevator down to the floor below the one it's already on. This is electron transitions. This concludes us discussing electrons. And so what I'd like you to do is do a quick summary of what we've discussed about electrons. And I just want you to write 4 sentences giving a summary and summarizing everything we've talked about on this video. I hope you have a great evening and see you in class.